Today's problem is police and thieves. Difficulty is medium. Given an array where each element contains either a P for policeman or a T for thief, find the maximum number of thieves that can be caught by the police. Keep in mind the following conditions. Each policeman can catch only one thief. A policeman cannot catch a thief who is more than K units away from him. What is K? Okay, so actually over here we can see the method signature, catch thieves. We have that the input array coming in with the letters T and P, and we have an integer K. All right, let's look at an example of how this would work. All right, so this one here, this first policeman would catch this thief. This thief would be caught by this policeman, and this thief would get away. All right, so you can get two. Two thieves can be caught with that input. I'm sorry, and also with K equal to 1. What if we use this example? Here's the array, and K equals 2. Well, actually, let's look at how we might be able to work through this, okay? We'll keep two lists. We'll keep a thieves list, and we'll keep a policeman list. And we'll go through the array and keep track of the indices at which each of these occur. So at index 0, that is a thief. At index 1, thief. At index 2, policeman. Index 3, policeman. Index 4, thief. Index 5, police. All right, and then we start out with a pointer at the beginning of each list. We go through the list, and we check and see if the current thief and the current policeman are within the threshold. In this case, 2. So we've got 0 and 2. The policeman will catch that thief. It's within 2, so let's keep a count of that. That's 1. And then we advance the pointer, advance both pointers. We've got 1 and 3. That's a catch. So now we have 2. We advance both pointers, 4 and 5. That is a catch. And so the total is 3. Output is 3. All right, there's one other possible issue here. Let's see how I want to do this. Okay, yeah, there's one other issue that you can't see from these examples, and that is that either the thief index or the policeman index can get too far ahead, too far behind, and have to be adjusted. So let's look at that. Actually, we could use the first example for that. First example, let's say that this T, instead of being a T here, this is also going to be a P. All right, so now we'll make our list T, P. Keep in mind the K in this case is 1. Index 0, policeman. Index 1, policeman. Index 2, thief. Index 3, police. Index 4, thief. Okay. Start the pointers here and here. Let's see, 2 and 0. Is that within the threshold? It isn't. That's a problem, actually, because this policeman is too far behind. This first policeman here is never going to catch anybody. Okay, so because of that discrepancy, we got to advance just the policeman pointer, all right, to catch up. All right, now we look at the current pointers. We have 1 and 2. That is a catch. Advance both pointers 4 and 3, and that is also a catch. So the answer is still 2. But we may encounter conditions where the thief pointer or the policeman pointer gets too far ahead or too far behind, depending on how you want to think about it, and we have to increment it if it's not within the threshold, because what that means is either that policeman is never going to catch anybody or that thief is never going to be caught. All right. Let's actually, yeah, let's just take the drawings off and look at the code for this. Okay. All right, so here are our two lists. We got the police list and the thief list. Can I highlight those? All right, police list, thief list. This is iterating through the array and putting the indices in the appropriate list. All right, now we'll initialize some variables. How many thieves have we caught so far? None. The pointer for the police indices, pointer for the thief indices, again, those both start at 0. I don't like this because we can't see it. What if I pull it over a little bit? Would that help? Oh, it does. Okay. So if we're going to do this until we hit either the end of the police index or the end of the thief. I'm sorry, the end of the police list or the end of the thief list, or both. So we get the the current indices from the pointers, and we look for the police index and the current police index and the current thief index. Take an absolute value, and is it within the threshold K? If it is, increment caught thieves and increment both pointers. If there's not a catch, that means somebody is outside the range. Somebody is outside the range, like that like the example that we looked at in number 1 there. So if the current police index is too low, then we've got to increment it to catch up. Okay, if otherwise the thief index is too low, and we've got to increment it to catch up. So at the end of all this, we should have the number of caught thieves, and we can return that. So let's try submitting that. Okay. All right. You know what I forgot to look at? Can I get rid of that geek bit? You know what I forgot to look at is complexities. Okay, so it's O of n. You know, it's just a linear algorithm. And company tags. Microsoft likes this question. Topic tags. Greedy. To me, it's more of a 2-pointer algorithm, but okay. All right, so that one wasn't. That one was not so bad. That was like on the low end of medium. Please like the video, subscribe. If you subscribe, then you will get these every time I post them, which should be every weekday in your inbox. And we'll see you next time.